In this video, we're looking at how to solve a quadratic equation using the square root method. So the basic idea here is we're going to take the square root of both sides of the equation because on either side of the equation we have something squared. So here's an example here. We have x squared is equal to 49 in the upper right-hand corner here of your screen. The x squared is equal to 49 can be solved by taking the square root of both sides. When you do that, the only thing you need to remember though is that you're going to take the square root of the left side with the variable, and that'll be equal to plus or minus the square root of the second side. The reason why we have to do plus or minus is because we don't know what number was squared to give you 49. When I take the square root of x squared, it gives me x. When I take the square root of 49, I get 7. And the reason why we have the plus and minus is because I could plug in positive 7 squared and get 49, but I could also have plugged in negative 7, squared it, and got 49. Once you square something, you lose its sign essentially, right? Because all things that are squared become positive. So we never know if the original value that was squared was negative or positive. That's why we have to account for both solutions here. Okay, so with this little example in mind, let's go ahead and try to do examples A and B below. So looking at example A, we're going to take the square root of both sides of the equation. So I'll take the square root of the left side. So 2x minus 3 quantity squared is going to be square rooted, and then we'll have, remember, plus and minus the square root of 25. And so when you take the square root of the left-hand side, those cancel out, giving you 2x minus 3 is equal to plus or minus the square root of 25. That's going to be plus and minus 5. Now from here, what you get is two basic equations. So you get the equation 2x minus 3 is equal to 5. And 2x minus 3 is equal to negative 5, right? And then you can solve by moving the 3 over to the other side. You get 2x is equal to 3 plus 5. Remember, when it goes to the other side, it becomes positive. So we'll have 2x is equal to 8. And then we divide both sides by 2, giving you, of course, the answer x is equal to 4. All right, so that's your first solution. Let's do the other one. So we'll add 3 to both sides, right? Just using the alternative form of the addition property of equality. Then we end up with 2x is equal to negative 2. And if we divide both sides by 2 here, we end up with the answer that x is equal to negative 1. All right, so we get two solutions for the equation. You can check both of them if you'd like, but I believe that those are both correct because, for example, 2 times 4 is 8, minus 3 is 5, and 5 squared is 25. But also, negative 2 minus 3 is negative 5. If you square that, you get 25. So both of these answers work when plugged into the equation. Okay, let's take a look at example B then. For example B, before we can take the square root of both sides, we really have to move this negative 16 to the other side and make it positive 16. So it'll be 3x minus 2 quantity squared is equal to 16. So we need to rewrite the equation so the constant is on the other side of the equation. Then we take the square root of both sides. So we'll have the square root of 3x minus 2 squared. And that'll be equal to plus or minus the square root of 16. Now the square root of the left-hand side cancels out the square. So we end up with 3x minus 2. And that'll be equal to plus or minus 4. And then we solve these equations separately. So we'll have 3x minus 2 is equal to positive 4, and 3x minus 2 is equal to negative 4. If we add 2 to both sides here on the one on the left, we end up with the answer 3x is equal to 6. And that must mean that x is equal to 2, right? We can solve that just by inspection. We can see that 3 times something is 6. That something must be 2. Likewise, if I add 2 to both sides here, I will end up with 3x is equal to negative 2. And if I divide both sides by 3, I will end up with the answer x is equal to negative 2/3. So those are your two solutions. And again, you can plug them into the equation to check to confirm they are in fact correct.